Morning. Am I audible to you guys?
Yes, ma'am.
Yes, ma'am.
Okay.
Um,
Okay. In last class, I just gave you the formula of your Bayes theorem. Let me share my screen first. So last class, I told that Bayes theorem is mainly used for your knowledge when we are uncertain about some events. That's it. So you can also say Bayes rule. It's fine. Anything you want to say. So this is mainly used for uncertain knowledge when we are not certain about some type of events, like whether it is a rainy day or sunny day. The things are uncertain. We cannot directly say whether this thing is going to happen or not. It's not like we are 100% sure about something. Okay. So Bayes theorem, we can, what was the main equation? A, B, A, given A, B, B. What was this part? Means we are going to find whether the condition or hypothesis A is true or not, given that B is true. Okay. And this is called your likelihood. Okay. Posterior. So here this part is the B is true given that A is true. Okay. Then both A and B are independent variables. Okay. So this part you can also imagine it like P given cause system. Okay, so with the help of Bayes theorem, various applications are used, like mainly used for weather forecasting, or also help robot to find a path or any other problems where our knowledge is not certain for a particular thing. So based on the Bayes rule, there is another network which is called Bayesian belief network. So Bayesian belief network mainly deals with the probabilistic event and to solve problems which are not certain. Okay, so a Baye, it's just a probabilistic graphical model. And it basically represents a set of variables. And there are conditional dependencies. Remember, Bayes theorem is mainly based on your conditional probability. If some event is there, like I can say, I am happy when it is sunny. So my mood is basically dependent on the weather. So these are conditional events or probabilities. Okay, conditional dependencies. And it basically uses a directed cyclic graph. It's like so, because these networks are built from the probability distribution and also use probability theory for prediction and anomaly detection. Okay, here we mainly use for prediction like weather prediction and anomaly detection. Apart from prediction and anomaly detection, you can also use for many different decision making things with the uncertainty. Then you can use for diagnostic events, then automated insight reasoning and all. Okay. So in case of Bayesian network, mainly two things are involved. One is directed acyclic graph. Another thing is table of conditional probability. So whatever generalized form or Bayesian network you use to represent a certain scenario and solve a decision problem under certain uncertain knowledge is known as influence diagram. Okay, if you are making something, for example, we have different nodes. Okay, and these nodes are like dependent on each other like this. So this is node, these are arcs. So this is basically a DAG or directed acyclic graph. So each node corresponds to a, these are nothing but random variables. Okay, random variables. And these variables can be both continuous or discrete. So these arcs or arrows basically represents the causal relationship or conditional probability between random variables. It basically gives you causal relationship, or you can say conditional probabilities between your random variable. So these links represent that one node directly influences the other node. And if there is no directed link, that means the nodes are independent with each other. Okay, so here A, B, C, D are random variables represented by the nodes, or you can say it's a network graph, or you can say influence diagram. Another word is influence diagram. So here you can see from B is connected to the node A by a directed arrow. Okay, then node A is called the B. So A is connected to both B and D, so it's more like A is the parent for both B and D. And C is kind of independent of A. C is not directly connected to A. So we can say C is independent of node A. Okay, it is dependent on B or D, but it is independent of A. Okay, so here we mainly use the concept of joint probability distribution. So here, for example, okay, example is going to be a big math. Hmm, okay, example I'll give you just in the notes. Okay, so just know the concept. Okay, so we have a Bayesian leaf network, which is basically representation of nodes and arcs. Your nodes represents your random variables, and arcs represent the relationship between the nodes. And you can just find any solve any problem with the help of joint probability distribution, which is nothing but this equation. With the help of this equation, you can solve the problems. It's like given A, you need to find the event of A given that B condition is true. So to find that, the main equation is here. Okay. So based on Bayesian network or Bayes theorem, we have another very important network, which is hidden Markov model. So I'll just directly go to that part. Wait. Uh, Okay. So hidden Markov model is also a type of network. Hidden Markov network, you can also think like your Bayes network, which consists of some nodes and the arcs. And similarly, the nodes will just define some random variables, and arcs will define some conditions or the relationship between your nodes. Okay. So first thing you have to know is the Markov chain. So Markov chain basically tells you something about the probability of sequences of your random variables. Okay. Markov chain will give you probabilities of sequences random variables or states, or you can say states. Okay. So each of which we can take over some sets. Okay. This set can be like you can represent as a weather. For example, you need to predict whether today is hot or cold. Okay. So again, for hot and cold, maybe there are other conditions. So you can represent like today can be a hot and can be a cold. There is a chances that it is hot before later it is going to be cold, so there is a 0.8% chances. Okay, then again maybe from cold maybe later on it might get hot again, so again there is a 0.2% chances. Then again maybe from hot to cold it might change again. So it's like sequences of events, like even if you consider like 2 days or 3 days and you need to predict whether it is going to be a hot day or tomorrow will be a rainy day or next day will be a hot day again. So it's like a sequence of events. So you can represent with this sequences like maybe sunny, rainy, again next day is going to be sunny, then again rainy, like this. So this sequence of probability of events you can call Markov chain. Okay. So Markov model assume something. It has an assumption on the probabilities of the sequence. Then, when predicting the future, the past does not matter. Only the present matters. Okay, so that's the Markov's assumptions. It just assumes that when predicting the past doesn't matter. Only the present. You can also represent with the equation like probability of conditions qi maybe equal to E, given that u1 to qi minus 1 equal to qi equal to E qi minus 1. Okay, it mainly depends on the present. Okay. So a hidden Markov model allows us to talk about both observed events and the hidden events. The name is hidden events. So Markov model tells you gives you two things. One is observed event. Okay. Observed event means whatever words we give as a input. Okay. Then there is hidden events. Hidden events is like something which are basically dependent on your conditions. Okay. So let's just see an example. It will be easier to understand. Okay. So let's suppose there is two persons. Okay. Alice and Bob. So for Alice and Bob, Alice know that the Bobs get happy when the weather is sunny. Okay. And Bob gets sad when weather is rainy. So we have two names, Alice and Bob. Then some knowledge about the Bob is that Bob is happy when it is sunny. And Bob is sad or grumpy when it's rainy. Okay. So we can say that means every day Alice talk to Bob. Then whenever Bob says today I am happy, so Alice can assume that okay today is sunny. Then in certain events, Bob must say like okay I am sad today. Then Alice will just infer that today is rainy. Okay. Then in sometimes what happens, Bob says it is happy, but it turns out that that is a rainy day. Okay. And again, sometimes Bob never says anything whether he is happy or not. So Alice keeps thinking whether it's a sunny day or a rainy day. Then suddenly maybe Bob says, okay, I'm happy today. Then she can infer that it's a sunny day. So we can just represent it something like maybe sunny. We have one node and we have another node rainy. Okay. So Alice's mood is basically depends on two events, which is sunny and rainy. Okay, maybe I can say Alice is sorry, Bob is happy when it's sunny is like 0.8% true. Means probability that Bob is happy and today is sunny is 80% chance. Then I can say in some events he might be sad because there are other factors even involved. So even though it's sunny, he might be sad. Okay. So and the chance is like 0.2%. Okay. So same thing can be happen in case of rainy also. So it's like sad, I can say 0.8% and happy is like 0.2%. Then in some places, it might be like he is not sure whether he is happy or not. And initially, maybe he didn't say that. So it can be that sometimes there's a probability her implication that today is a sunny day can convert into a rainy day 0.2%. Then again, there are some other probability involved, like rainy day will become sunny day is like 0.4%. And maybe in whole week, one sunny day is followed by another sunny day. I come to the whole point later one by one. And there is another probability like 6. So these are the main observation. What is your observation? Or Alice's observation is that Bob's mood is either happy or sad when the weather is sunny or rainy. So these are the conditional probability of Bob being happy or sad based on the sunny and rainy day. Then these are the hidden states. Hidden why? Because sometimes it's just uncertain about the weather. Okay, and if it's like continue, you take the whole week, then there are some probabilities that today is sunny, tomorrow sunny, then next day is a rainy day. Okay, so these are the transitions or things we are not sure. So these are the internal steps, or you can say hidden states. Okay, so this is the representation of your hidden Markov model. Okay, so now some questions might come like, how do we find these probabilities, right? Then what's the probability that a random day is sunny or rainy? Okay, we have to think about like what's the probability that today is a sunny day or rainy day. It can be any random day. And another question can be, if Bob is happy today, what's the probability that it's sunny or rainy? Okay. Then another question can be, if for 3 days Bob is happy, sad, and happy, what was the weather? Okay, Alice may be talking to him like for 3 days. So one day Bob is happy, next day Bob is sad, then third day Bob is happy again. So what was the actual weather for the 3 days? So again, there are some probabilities involved in that. So let's say uh, let's say first day is sunny, then second day is sunny, then third day is sunny, fourth day is sunny again, then one day is rainy, the second day is rainy, then again third day is maybe rainy, then again it comes like sunny, 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 and sunny. Then we have again rainy days like rainy, rainy, and again then comes up sunny, sunny, and sunny. Okay. So how to find the probabilities? How many steps we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, or 16 days, for example. Okay. So you can see what are the probability or certainty that from one sunny day, next is also a sunny day. From sunny to sunny. From sunny to sunny, 1, 2, 3, 4, again 5, 6, 7, and 8. So 8 times in a 16 days. I can say just 0.8%. Then maybe sunny to rainy. Okay. So sunny to rainy 1 and 2. So 2 days sunny to rainy transition, I can say 0.2. Then I can find rainy to sunny. So rainy to sunny, rainy to sunny, and rainy to sunny. Okay. So again 2, I can say zero point 0.2, and rainy to rainy. That means you have to find out all the probable conditions from transitions, like it can be sunny, next day will be raining, then again from rainy to sunny, then whether sunny to sunny or rainy to rainy. Okay, so from rainy to rainy, 1, 2, 3. So total 3. So these are the probability or hidden steps we have seen here. Okay, from sunny to rainy, rainy to sunny, sunny to sunny, and rainy to rainy. These are the sequences you found out. Okay, so again, remember how to find this happy sad thing. Again, based on the sunny thing, we have to find out happy or sad. Okay, maybe even though it is sunny, that day Bob was sad. Okay, and next day, 3 days, he's just happy, again happy, maybe happy. So maybe your prior probability is given that 2/3 times Bob is happy when it is sunny, and 1/3 is like Bob is sad when it is sunny. So these are like your prior probabilities. 2/3 when it is sunny and he is happy, and 1/3 probability is that it is sunny but he is still sad. Okay, sunny and sad, sunny and happy. Okay. So maybe here for the day again it can be sad, sad. Maybe one day he's just happy. Okay. Then again for sunny day, maybe first day he is just sad. Then next day he is happy, again happy, again happy. Then again for rainy he is just sad, or then one day he is happy. Then next day he is happy. Okay. So with these conditions, how many times it is sunny and he is happy? 1, 2, 3, 4, 5, 6, 7, 8. So 8, it's again 0.8 times. How many times it's sunny but he was sad? 1 and 2. So 2 is zero point 0.2. Then you can similarly say it was raining and he was happy. Okay, so probability is like how many times it happened. Rainy and happy 1 times, rainy and happy 2 times. It's like 2. And rainy and he is sad. How many times? 1, 2, 3. It's 3 times. Okay. So you can see here we have like 10 happy days and 5 rainy days. Okay, initially we had just sunny and rainy, right? So we had sunny equal to 10 days and uh, rainy day was like 5 days. So initial condition was 2/3. That's what I meant. It's like prior conditions 2/3 was given. So based on this, you just found out whether next condition is sunny or not. Okay. So from here, we build the first conditions like from sunny node to rainy. First was sunny to sunny, condition was 0.8%. Okay. And rainy to sunny was, okay, it was your 0.4. Rainy to sunny, 0.4. Okay. So condition for sunny will be 0.8 sunny days plus whether today is sunny or rainy. How will you calculate? The probability, main probability of today sunny is 0.8% and 0.4% rainy day. Okay. Then again, you will see the same thing from rainy to rainy. 3.4 and it was 0.2. So from rainy to rainy, I can say 0.2 sunny plus 0.6 rainy. Okay. So, and both sunny and rainy has like equal chances. I can just write 1. Okay. So I can just say sunny equal to 2 by 3, which is already given for us 1 by 2. Okay. And again, we can also see whether today's weather is sunny or rainy. So we already know have it like 2/3 probability today is sunny, 1/3 probability today rainy. So based on that, we can calculate whether he is happy or sad, like here. So this calculation you can do with the Bayes theorem. So hidden Markov model is also like joint probability, and you can calculate these things with the help of Bayes theorem. For example, maybe just example, okay. 2 days are sunny and 1 day is rainy, right? From this one, okay, 2 by 3. 2 days sunny and 1 day rainy. Then we have observation like maybe happy, or maybe 4 days happy, 1, 3, 4, and last day he was sad. Okay, here also like 4 days happy continuously, then 1 day sad. Okay, then for the rainy part, maybe he was just happy for 2 days, then most of the times he was just sad. Okay, so here you can find the number of happy states. Okay, and from here you can find number of sad days from this condition. So here you can see one. Okay, from here part also, you can say this part is like 0.8 per, and here is only 2 observation is 0.2. Here it was like 0.4 total, it is 0.6. Okay, so with the help of Bayes theorem, how you calculate this? If he is happy, okay, so probability that it is sunny and given he is happy. Okay, you can find out there is 8 observation out of 10, and for P it is rainy given that he is happy. Okay, again for it's like only 2 out of 10. So similarly, you can find the conditions for sad. Okay, so if sad, again you can find sunny given it is sad, it will be maybe 2.5. Then again you can find out rainy and it's given sad. Okay, this is like pure mathematics are involved. Was 3 by 5, I guess. Okay, so from here you can find the sequences like whether sunny Thursday, Wednesday or Thursday, whether it can be today's sunny, next day will be sunny, and on. Okay, based on this one you can just again draw the chains like happy, sad, sunny, rainy. The chain will maybe like this one. Okay, so this will be as your Markov chain, and whole model is like Markov model. Okay, so based on these diagrams and conditions, you can predict whether someday, maybe 2 days later, whether it is going to be happy or sad day. or same thing is also involved if you want to forecast weather conditions. Okay, so that's all for hidden Markov. I just suggest you guys just go for a bit more sum. Maybe I can give you assignments to do some problems, even though in exams I'm not going to give problems involved in hidden Markov model or Bayes theorem, but your concept will be more clear. Okay, so these are just the basic concepts. Both are interdependent. Okay, so Markov model, two things: observed events and the hidden events. Okay, and here I said it does not care about the past. Your next situation is only based on the maybe next, means based on today's events I can predict tomorrow things. Okay, so it's not like I'm going to take the whole past history. Okay, was I mute all the time?
No, ma'am.
Okay, suddenly I saw unmute yourself, then I got scared and I like, how come no one told me? Okay, anyways, thank you. I'll just switch on your videos for a while. I was audible, right?
Yes, ma'am.
Yes, ma'am.
So today is a rainy day. Okay, thank you all. Your second sessional exam will start from 4. Okay, we will we will share the time